Come back. Problem number 2323. Find the minimum time to finish all jobs. You are given two zero-indexed integer arrays, jobs and workers of equal length, where jobs of I is amount of time needed to complete the ith job, and workers of j is the amount of time the jth worker can work each day. Each job should assigned to exactly one worker such that each worker completes exactly one job. Return the minimum number of days needed to complete all jobs after assignment. Okay, so we have this one here. We will have the output should be 2. Let's read the explanation. So basically we assign the second worker to the first job. We assign the second worker to the first job. It takes them 1 day to finish the job. Okay. We assigned the first worker to the first job as well. So this will take I guess this will take in the position number this one as well, because it takes them 2 days to finish the job. We assign the first worker to the second job. It takes them as well 1 day to finish the job. So it takes 2 days for all the jobs to be completed. So return 2. Because of that, we return 2. Because as you can see, number 7 can finish these two jobs. These job, I guess, and number 1 could finish this twice, and this could finish this. So we have only 2 days. Let's think about that. So in this one here, we have again we said the second worker, which is this. We assign the second worker the first job. This is the one we take it the first job, and this one takes this job, and this one takes this job. How can we solve this problem? So let's take this as an example and see how we can do that. Let's go to our beloved board, Miro. We will have two arrays. The first thing that I will think about is to sort them, because sort the jobs array in descending order. This allows us to handle the hardest job first. And after that, we sort the workers array in descending order. This allows us to assign the hardest jobs to the most capable workers. So let's do this one. So it will be 5, 4, 2, and we will do the same here. 7, 5, and 1. Oh, no. And 1. After that, when we sort it, it will be way more better for us, because right now the hardest job will be assigned directly to the toughest workers, or the workers that has the capacity of it. After that, for each job, we should find the maximum time taken by any worker to complete that job and update the maximum days required accordingly. So the steps we will do that, we sort both jobs and workers as we do here. So let's just rewrite them again here. So the jobs, it will be 5, 4, and 2. And jobs will be 7, 5, and 1. And after doing that, we should initialize a variable we call max days to keep track of the maximum number of days required. And after that, we iterate through the jobs array and assign each job to the corresponding worker in the workers array. And for each assignment, calculate these days required by the worker to complete the job has updated the max days. If this value is higher, we return max days as the result. How this will be done by the code, let's do it here. It will be quite fast to do it. First, we sort, as we said before, so jobs dot sort, and we do in the ascending. So A, it will be, and it will be B minus A. And we will do the same for the workers. array. Right now we sort the jobs and the workers in descending order. After that, we create the max days variable. This will keep track, or you can imagine this as a counter. After that, we create a for loop here, and it will be let I equals 0. I should be less than jobs dot length, and I will be plus plus, and I would say const days will equals the days will equals. Basically, we will need to calculate days required for worker of I. So for each worker to compare jobs of I. So how we can do that? Days will equals the math dot seal would be jobs of I divided by worker of I as well. And I would say if max days will equals math.max what's already in max days and with the days we have. After that, we return max days. Okay, let's try to discuss what we have done here, because it looks quite simple, but some of you will not be able to understand what exactly happened. I find it I don't find it that easy to understand this solution, specifically because it's 3 or 4 lines of code. So first we sort. So we sort the jobs in the ascending order, and after that we sort the workers in the ascending order. And after that we initialize the max days. Then the max days equals 0. This variable keeps track of the maximum number of days required among all assignment. In the loop, we assign jobs to workers in the loop. So basically, we iterate through each job and assign it to the corresponding worker after both arrays are sorted in the ascending order. Okay. And after that, we have the const days equals math.cell jobs of I divided by workers of I. So we calculate the number of days required for we calculate the numbers of days required for the current worker to complete the job. Use math.cell because a worker cannot work for a fraction of a day. So after that we update the max days. So max days we update it here. So basically we update the maximum number of days required if the current assignment requires more days than previously recorded in the max days. And in the end, we just return the max days. After iterating through all jobs, we return the maximum number of days required. This approach ensures that we assign the most difficult jobs to the most capable workers, thereby minimizing the total number of days required. The time complexity is n log n due to the sorting step, which is efficient given the constraints. Let's try to submit it and see if it will work or not. It worked, and we are beating only 46%. Let's submit again and see how it will do. We hope, okay, we're beating 100%. It just like, it looks like we are like killing it, but as you can see, basically, we did it in 170 milliseconds. The other have done it in like 200 milliseconds, so it's not that big of different in time, to be honest. So that's it for the solution, and I hope you like the video. If you have any comments, just feel free to ask, and I will ask anytime. I will answer anytime. So yeah, see you in the future.